My name is Pavel Chinaev. I'm continuous delivery architect at Live9 IT Services. With my daily work, I help our customers to assess, create, and optimize the way they deliver their applications to production. This is what I love to do. This is my passion. This is why I'm standing here and sharing this with you. So what I'm going to talk about is mostly what I have implemented myself, or what my colleagues have done, or what community on the meetups or people I talk to have implemented. So these ideas come from all the sources, from everywhere. Some of them are theoretical, but yeah, they all apply and they all make perfect sense, and yeah, you will see. Questions are very welcome. Disagreements are very welcome. And if I manage to introduce in yourself some thoughts like, oh yes, but what if, then I think that I made it a success, because the main idea is to get these ideas to you and to get them inside your head, and then you can start doing something. What we're going to do here is that I'm going to quickly talk about continuous delivery process. Then I'm going to focus on testing, releasing, and then some closing ideas. So there is always a gap between advice that you can give, a general advice, and some specific advice. And I believe that it's really, really hard to give exact specific advice without being exposed to everyday work, without having spent a day, a week, a month, or several months in environment. But also it's bad to give general advice, because this advice, well, they're good, but they are not applicable to anything. So I will try to balance between those two and give you some ideas that are general, but also some ideas that you can start implementing. But I can't make this work for you. I can't tell you need to do it like this. It will be your job to do it. To find out what exactly you need to implement the next step, and how exactly will it be implemented. And you will tell me if I succeed with this or not later today. Yeah. Okay, quickly about me. So, again, my name is Pavel Chinaev. I started working in 2004. I come from Ukraine. I used to live in Estonia from 2007 to 2010, when I returned to Ukraine to join Live9. In October 2014, I moved to the Netherlands. Now I continue working here. I love cycling, and I needed to move here to figure this out. I would never cycle in Ukraine and Kiev. This is crazy, but here I do it every day. Well, maybe not every day. Today I cycled from Utrecht Central, or I didn't cycle from Utrecht Central. I use public transport, so it's not that I really love cycling, but I do it. I have a road bike, and I rode up Alpe d'Huez last year once. Then I participated in the Hollands 100. This is an event organized by Bernard van Anje. He is one of the Live9 co-founders. 10 kilometers ice skating, 90 kilometers cycling. It was in March, to raise money to fight lymphoma cancer. And 90 kilometers was an achievement for me. I tried to do 10 kilometers ice skating. I failed. I did only 3. But before December last year, I didn't know how to skate. So it was in December my first time on skates on ice. And the first round I did in 40 minutes. Then at the end, before March, I could do it in 3 minutes. So, but still I didn't make it 10. And also with the cycling, this year I rode 2 times Alpe d'Huez. One time faster than the last time, and the second time it also was an achievement. So I will progress there. I love Dutch language. Well, love. I'm studying it. I'm now at the phase where I can read, and I push myself to read everything in Dutch, because, well, I can read in English, obviously, in Russian, Ukrainian, but this is not the point. I can understand almost everything on TV, but when people talking, not yet. Projectile is something a bit what I'm having trouble with, but I will improve. And talking is at the same category. I can speak, but not very deep and things, but I will improve there. And for a year and a half, something, I believe this is already good. If you have some piece of advice how I can do it better, please give it to me. Very good. Additionally, I love software development processes. Again, as I mentioned, this is why I started sharing this. I love to see how things are done, how I can streamline and help teams to easily deliver value to production. And this is, again, why I'm sharing this. And I love working with people. I believe that I can learn a lot from people, I believe people can learn from me, but I like working in teams and yeah, having those ideas exposed. And yeah, I believe in people and I trust that people can do the good things, and it depends on people, not on processes or anything, how things will work. Well, having finished the introduction, let's move to continuous delivery. So, first I would like to show the general, what I think continuous delivery is. Many people think something different. I will give you my view. I can't agree that it's only about environments or automation. I see a bigger picture here, and I see this picture. It's not even about continuous delivery, it's about how any idea is being implemented and pushed to production. This is how it works. It starts from this idea generated by somebody who knows the product. Then it goes through planning, refinement, and development. The magic happens there. Then we go to the stage where continuous integration goes in, then testing, then releasing, and then operation. And the thing here is that in a lot of cases, not every feature that was implemented by developers is actually needed by users. I don't know exact statistics, but I think 30 to 40% of features that they implemented are just not needed. They're not used by users at all. And this is a waste of effort, a waste of time, it's a waste of money. And this is why people talk about validating ideas. Okay, we have an idea of what users might need, but you won't know that users really need it until this idea is working in production. And this is why people started moving to faster and faster release cycle, because you want to make this time shorter between, okay, let's try this, before users are really exposed to this feature. And then you can see, this is what is needed, or this is not needed. And then you can make a decision, let's make more of these features, or add features to this feature, or implement it in a deeper, or some more bells and whistles. Or let's stop development because nobody is using it. And then people start doing faster, 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 creating shorter and shorter release cycle. And then we need to really release, as a result, more software in less time. And this is where whole IT market is where it is now. We need to do more in less time. But if you think of this, I say that the quality is more important than speed. And if we focus on quality, speed will come, everything else will come. But if you don't focus on quality and just start improving speed, what will you achieve? You will just churn out more and more defects to production. And probably nobody is going to be happy about it. So only when you focus on quality, you can get everything else. You can get user satisfaction, you can get faster time to market, you can get shorter release cycle. You can't just churn out features. And also this means that, and what I truly believe is that the quality can't be established through the manual testing. It just, well, manual testing can be done, but quality is not established through it, but through something else. You can establish quality through by keeping the product releasable and by building the quality into the process. And these would be the two main ideas in this presentation that I want to pass to you in your software development. Keep the product releasable and build the quality into the process. And I will talk about ideas how you can do it. And the main thing that I'm promoting is the idea of build, test, release cycle. It belongs here. So whenever you finish development, this is where you can start automating things. And this is where I see a lot of people struggle. How it looks like? It looks like this. This is what the pipelines are about. On one part of it you get the source code. Then on the other part of the pipeline you get working software. And it goes through build, test, and release phase. And this is a reproducible and repeatable process. And whenever you want to make any change, even this quick hotfix, it needs to pass the same process. And then the main advantage here is you know how much time it takes. So if you want even to produce an urgent hotfix, you will know how much time it takes to go through the whole pipeline. Because this is all the steps you need to make to release something to production. And this is how we make a product potentially shippable and keeping the product releasable. What belongs to those stages? On the build stage, we do everything that makes sense to do with the source code, to check that we are still good. It can be linting, static code analysis, static security code analysis, it can be unit testing, integration testing, whatever we do with the source code. And if something fails here, we don't go further. If all these tests are fine on the level of the source code, we finish, we compile or we assemble, and then we create binary artifact, we version it uniquely, and then we move to the testing stage. With the testing stage, we do all the testing that is needed to ensure the quality of a component, or this microservice, or the library, or the product. All the testing, all the criteria you want to check your application against are tested here. And tested all the time, all over again, constantly. Because then you want, if something goes wrong, you want to find it immediately. You don't want to find it later in the process. But this is important because this is one of the changes how you do the testing. Who does it? It needs to be automated and it needs to run simultaneously. If any of these tests fail, you don't go further because then there is a bug in your application. But if everything is fine, you move to the release. This is where release can mean a lot of things. But generally, this is when you make your application available downstream or available to users. Because it is stamped already, quality is assured, we can use it. Or users can consume these new features. And this is why we're doing this, to move it to release. If you think how we do the testing, the ideal situation is that, again, you do all the tests in parallel, and you limit the time it takes. But here is the big thing. Here it says, it can be read here, it says provision infrastructure, and here it says dispose infrastructure. The idea is that you create all the infrastructure needed for testing just in time to do the tests. You don't have detached street with the shared environments that are used by shared people or by tests that you create. All the environments that are needed to run the test, and you create them from the scratch. You know how much time will it take, and you then dispose this immediately afterwards. This is the concept of immutable infrastructure. And then you can make it identical to production because you constantly create it from the scratch and constantly destroy it. It will never get dirty, it will never get any manual hacks, because it is always created from the scratch using the same exact step, and you always know the resulting state is going to be. And this is the state that is needed to run this particular test, or this particular test. Then you can see some types of tests here run parallel. So end-to-end tests are notoriously infamous for taking too much time to run. Like hours, some companies days, and you have to run them in parallel because you want the feedback of the test to come quicker. And this also means, and I will talk more about this, that you need to be able to split the tests, to be able to make the tests that don't require any specific data, that don't make assumptions, and can be restarted any time. Again, I will talk about the shortly. But this is how testing should be done.
So, does it mean you have to recreate the production environment in the testing environment, including all the data to do the tests, or?
So you need, you don't need, that depends on test. So if your test requires the data needs to be created. What you can't do is that say, okay, this test will require the data that was created by previous tests, because then the whole construction will fail. But generally, yes. If the data is needed to run a test for that particular thing, it needs to be there. It needs to be recreated. And the idea here is that if you are able to create the test to to create environment to run the test. You can create environment to run the test locally while you're doing development. Exactly the same environment. To be sure that when you commit, it will be okay. To be able to reproduce bugs. The biggest thing that I see is that when there are these tests or acceptance environments that are used by a lot of people, and people just, well, they can't live together. One test is breaking another test, one person is doing one thing, and then another person is doing another thing, and then some assumptions appear, okay, this data was there last week, but suddenly it's not here now. Why was it there? There, no clue. But then if you know the process of creating an environment, putting the data, you know the starting state, and you can always say that my test requires this starting state, nothing else, then from infrastructure and default data. And if some test creates something else, it's up for those tests, but they can be removed, not removed, but no assumptions are made further. Okay?
So this would mean you have these multiple redundant environments for those simultaneously running tests, right?
Yeah.
Yeah.
But this is, I would say, the price of testing. If you want to test quicker, well, again, I will shortly talk about this, but the idea is that you want quick feedback loop. You committed something to the source code, you want quickly get feedback, is it okay or not? Is it a working piece of software that I've created or not? Was the change good or not? And the faster we do it, the better, because the sooner you find the bug and the sooner you fix the bug, the cheaper it is, the faster it is to fix the bug. Ideally, you should fix the bug, you should find the bug and fix the bug while you're still thinking in the feature you were implementing. Not 2 days later, not 1 month later, not 3 hours later, but ideally 1 hour later maximum. This is where you haven't yet switched the context completely. You still know all the details, so you can quickly fix the bug. But in order to find it, we need to quickly assess all the software to test it and be sure that everything is fine. And this needs to be done for every change, because every change is potentially can ruin your application completely. And you want to find this immediately. You don't want to find this a couple of weeks later. The testing pyramid. So you probably know about this. Who have heard about testing pyramid? Okay, good. I will explain in more details what I say about testing pyramid. So testing pyramid shows the even shot. It shows the amount of tests that need to be created for any application system that you're running. Most unit tests, bit integration, contract tests, I will talk about those, end-to-end tests, and here all additional tests, including manual, almost none. This is the amount of testing. And testing pyramid has some more perspectives here. First, the perspective of execution time. When we move from the bottom to the top, execution time increases. Unit tests take milliseconds to run. Integration tests, well, seconds maybe. Contract tests, minutes. End-to-end tests, hours. And manual tests, days. So we move to the top, execution time increases. More goes with the perspective. The more we go to the top of pyramid, the more feedback we give to business. We are building the right thing. Because end-to-end tests show how users interact with the system. And if end-to-end test fails, the product manager knows this feature is broken. But if end-to-end test fails, where is the bug? Good luck finding it. And you will spend hours to find out where the bug is if you're a developer. On the contrast, towards the bottom of the pyramid, more feedback to development comes. If unit test is failing, you know immediately as a developer where you should start fixing, but it provides no feedback whatsoever to business. Which feature is broken? Who knows? And this is the idea that you need both. You need all this perspective. You can't just focus on technology test, or you can't just focus on acceptance test. You need to have both. You need a combination. You need to provide feedback to business. We're still building the right thing. And you need to provide feedback to development. We're still building the thing right. Okay. I will quickly talk about the testing pyramid and how it applies to the microservices architecture. But just to keep your minds open, it doesn't apply only to microservices. Monolithic applications are built in exactly the same way, and should be built and tested in exactly the same way. It's just a different way you put stuff. Do you put the service separated, or you put it as the module in your application? The story should be the same. But if you look at the microservice architecture, and again, monolithic is probably exactly the same, it looks like this. There are a couple of services, objects, that communicate between each other. They have some databases, they have connection to external services, they communicate either directly through some APIs or through event bus, some users interact with this, all sorts of things are happening here. Again, monolithic application, it's all the same, just it's packaged in one application. So how does it look at from the testing pyramid perspective? What kind of testing and what do I mean here? So first of all, of course, unit testing. And this is simple. This is your object, your method in isolation. You are ensuring that it's working as it is designed to be. And of course, you're not aiming for 100% coverage. It's a good metric on itself. But what you should focus about is real testing. Is your method working correctly? Is your object same? So it's not just cover, because reaching 100% coverage is super simple. You just write at least one test method, but will they be useful? Maybe, maybe not. And it's big art to create correct unit test. A lot of books are written for about this, and this is something that you need to learn to do. It needs to be just part of your culture to create unit test. And it's not something really hard or impossible to do. This is what people are doing. And there are even ideas now, not ideas, there are products that test your unit test. In the ideal world, what happens is that you create the test, and then these applications, they test scenarios that your unit test should fail. And if your unit tests don't fail, you created a crappy unit test. So you've got more levels of testing if you want, but this helps you really creating the proper testing that will provide you proper feedback. And again, when it's broken, you know exactly what is broken if the correct unit test was created, and you know how to fix it. If we move to integration test is something that either some units communicate together or communicate to third-party services. If you ask me what object-oriented programming is about, I would say that it's about communication between objects. And this is what I think is the most important part of object-oriented programming, how objects interact with each other. And this is what you're testing by integration tests. How they're working together, how they exchange information, how they transform state of each other, or how they connect to third-party services. This is what we're testing here, so ensuring that how parts of application work together. And again, we need to provide these feedback, because if it's broken, your application is broken. Then if we move to level further, either it's microservice or a module, we need some kind of black box testing. I call it contract testing, because ideally what you expose is a promise. I, as a service, will provide you this functionality. I will provide you in this way. If you send me this request, I will give you this reply. This is a contract. This is a promise that you give to everyone else, to your consumers. Be it internal people, be it other services, be it users, wherever. This is a contract, and you need to test it because you don't want to break it. Because if you break the contract, anyone who consumes your service won't be able to do it, and they won't be able to work properly. Again, it applies perfectly to microservices, but it applies perfectly to monolithic applications. If you've got your module there that everyone consuming, it is still API, it's not external API, it's internal API. You need to test it, and you can't just change it and break it. Most problems, what I see from integration, are happening because people are breaking the contracts. It's easy to change it, and especially it's easy in monolithic applications because these things are hidden. You just change some things, you change how people should interact with the object, and suddenly some other parts of applications are broken. This is why you need to test this. You need to ensure that you can't just change it at will. You need to plan it. And I will talk quickly about how to change the contracts a couple slides later. But here it's also sometimes called black box testing. You test your application, your service as a whole, how it performs from the outside world. Then if we move to end-to-end testing in similar fashion to integration testing, it is the same. How different services integrate together, how they work together, how they communicate, or how the whole application works. But again, application consists of several modules or services that are working. And here the main thing is that focus on business flows. Don't test every feature on this level. Because you see, the testing pyramid says there should not be a lot of testing here. There should be testing, but not every feature should be tested like this. But business flow, you can think personas, how these personas use your application, what are their flow of usage, because then you will test indirectly all the features, but then you won't spend hours or days on this, because ideally you should find all the bugs here, 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 and then only then there. So this is what testing pyramid is about. Proper testing for each level. So there are different techniques here. Okay, people mostly think about end-to-end testing, about acceptance testing, for functional testing, Selenium tests. But I've seen teams implementing BDD, and it works perfectly for them. I've seen people who create API tests. Through API they create flows and integrate here. Just think about the whole application level, how users, whoever those users are, real users, applications that consume it through APIs, some internal people. Just think from their perspective, how they use your application and test it. Whole application. BDD I've seen useful because they the greatest thing was that the tests were created by product owners. What developers did is that they implement a dictionary of things. Okay, given that user is logged in, this is a dictionary, you need to implement the code. But once you got enough the dictionary, all the tests can be created by business people. And all the tests should be created by business people. If not, then they need to be created by developers. And the developers need to look through the eyes of users. Okay, I talked about before about the data independency. I won't focus about these again. But then one other thing is that whenever you find the bugs higher level, so through manual testing or through end-to-end testing, you need always to think how I could have found the same bug lower in the pyramid. Because again, the lower in the pyramid the test is, the quicker feedback it provides. Ideally, end-to-end tests should not fail ever. They should always be like a guard dog saying that everything's fine to business. All the features are still okay. If the tests are failing, they should fail here and give feedback to developers. But then, if end-to-end tests fail, ask yourself, how could I have implemented this through contract testing? How could I have implemented this through integration testing? Or through unit testing? So move all the tests towards the bottom of the pyramid. Now we'll talk about the contracts and about updating the contracts. So again, objects or services communicate together through event buses or directly through some REST APIs or SOAP APIs, and we just can't change it. So if you think about the about the service, yeah, it exposes some API that is consumed by other services. And here says v1.0. So you need to version your API, you need to version your application, but you need to version your API as well. And as much as I love semantic versioning, it doesn't fully apply to the contract, but I believe that, okay, in ideal world you will have only one version of API, version 1, and it will never change. This means that you've created a right domain model, and yes, you did a good job, and then your application evolves forever. This is, however, is something ideal that I've never seen in reality. And you probably were exposed to this as well, because you see people are transitioning, companies transitioning to version 2 of API and other things. And and version 3, and so on and so on. So people change the APIs, and you will need to change your API as well. So I believe versioning the APIs to major and minor, especially for the products that are in development, makes sense. Because if you take the rules of semantic versioning, if you introduce backwards incompatible feature, you change the minor version 1.1. If you introduce backwards incompatible feature, you change the major version 2.0. And then it sends a message to everyone else, to other development teams, to the users, what kind of change have you introduced. So this is why I'm specifying here 1.2.0. This is how I believe APIs should be versioned. So you introduce another version of API. You introduce a backwards incompatible change, or backwards compatible change, or even backwards incompatible change. It doesn't matter. You just can't stop producing old version of API because some users are still consuming it. You just can't break your contract. So you start doing two things together. You're allowing people to slowly migrate. And people start migrating to your new version of API. And only when everyone is there, only then you can stop exposing old version of API to your consumers. And this is not an easy process, but this is something that keeps your application releasable. This is something that keeps everyone happy. This is something that makes these transitions explicit. Otherwise, you just move quickly if you introduce 1.1. And again, in this example, this is backwards compatible feature. But this is hard to judge in a lot of cases. What is backwards compatible feature and what is backwards incompatible feature? For some it may be compatible, for some it may be incompatible. You don't know exactly how users have implemented it. Maybe they implemented it incorrectly, and then your backwards compatible change will break their stuff. You don't want to break your user stuff, you want to work with them to transition to a new version. And this is how you do it. And again, this needs to be done, I believe, for public or private API that is exposed outside or exposed inside, be it microservices, be it monolithic application, it needs to be the same. The top of the pyramid here, mostly I'm thinking about manual testing, because you will still need some explorative testing. And as a product owner or as a product manager, you will do explorative testing anyhow. But also here, a lot of different types of testing might be, like scalability testing, availability testing, resilience testing. You might want to do a lot of things here that might be needed to ensure that your application is working. One of the main things I want to also focus you is on resiliency testing, because especially if you're creating monolithic application, or especially if you're creating microservices application, it gets harder and harder, because what if this service goes down? The application needs to be still working. Maybe in a degraded way, but it doesn't need to fail. Or this service is down. What will happen? It's connected to some external database. Your application still needs to be working. Again, in degraded functionality, but it doesn't need to fail and stop producing any output to users. Or these two services, or event box. Your application needs to be working all the time, even at least if one service is working, that is producing some content to users or API to external consumers, it needs to be on. It can't provide all the features, but it needs to be still on. And this is what you need to test. You need to test it automatically. So yeah, this was the perspective of the testing pyramid in microservices. And one of the ideas and abstractions that I see here is that unit tests and integration tests, they are inside the microservice. We are testing units in isolation, then you test how they cooperate together. But if you think contracts testing is in a way unit testing, just for the whole microservice. And then end-to-end testing is in a way integration testing, just on the level of the whole application. It just depends where you put the boundaries. Is the boundary your microservice, or is the boundary your whole application? But you need all of them, you just can't go without. Quickly, some ideas regarding building the quality in. So, as I showed, testing is not just the presence and absence of defects. It's a valuable feedback to development and to the business throughout the whole life cycle of the application. And it's not a separate process. It's not something that we develop, and then somehow some people test it. You can't establish quality like this. It needs to be part of your process. And it should not just raise the cost of maintenance. What I also see is that, okay, we've got a team of manual testers, they know the test cases. Now you are automation testers, automation QA engineers. And they start automating all the test cases, and suddenly we've got 8 hours of test cases that they need to run. All of them are automated, there are 200 of them. They are constantly flapping, sometimes they work, sometimes they don't work, and people are busy always updating those testing. And if the testing is a separate process, it's always lagging behind. Some feature is implemented, the tests are failing, even though they are automated, because information doesn't pass. So you need to implement it as the built into the process. Otherwise, it will only increase the cost of maintenance. It will provide some feedback to you, some value, but not what you want to do. Stop thinking about functional testing only. Again, it's not only end-to-end testing. Most people who go on the passive automation testing make the mistake of automating end-to-end testing, and they create a testing pyramid that is what people call ice cone, where all effort is put on end-to-end testing, but no on unit, on integration, and construct testing. This is not the way to go. Quality goal needs to be established early in the process. So before you even start developing, you should know, okay, how will I ensure the quality? And what kind of quality I want to achieve here? Otherwise, it will be too late later. Ideally, your automated testing should be part of the definition of done. So the story is over when there is a test that will ensure that it is over. Again, only if you put it like this, it will take time to build up all the testing. But this will be part of an iterative process, and one day you will get there. Otherwise, you just can't start the process. Okay, let's now automate everything and introduce testing. It doesn't work like that. It needs to be part of daily work. It needs to be built in. Test early. This is what I was talking about. It's called moving test to the left. The earlier you start the testing, the better. The faster you find the bugs, the cheaper it is to fix the bugs. Some people say that TDD is required to test-driven development to ensure that the testing is there and the correct testing is there. I tend to agree with them from the perspective that it changes the mind how you do the testing, because before you start coding you need to create the test, and this forces you to think it through the eyes of the user. How will I ensure that what I'm going to code will be tested? But a lot of companies, a lot of teams that say it's too much, and they've implemented the process when testing is, when tests are created along the way. So you code and then you cover it with the test. As long as it's part of the definition of done, it's up to you. Do you want to create test before, or do you want to create test later? TDD is still kind of controversial, and there are still fights whether people should do it or not. But even if you don't implement TDD, but start thinking before implementing, how am I going to test it? It will already put you on the right track. And also the main part here is that testing is a shared responsibility of the whole development team. It's not somebody else's job. Okay. Testing on itself is not enough. You need also to have frequent incremental releases for early feedback, because testing provides feedback to development and to business that we are still fine, but it doesn't provide feedback from users who consume your application. And what we're doing is we want to put it into the hands of users to start generating money. This is what it's all about. And again, I've seen what's happening is that releases are problematic, they're hard to do, and people do them less frequently because they're hard to do. But actually, it should be the other way around. It's hard to do, it's painful, let's do it more frequently, because then we will gain mastery. Repetition makes it mastery. If you are doing 4 releases a year, you won't be good at it. If you're doing releases every 2 weeks, you will be a lot better at it. If you're doing releases on every commit, you will automate and you will make sure that the process is stable and working okay. It's a long journey, but you need to take it one step at a time. But again, most important is that you get feedback from real users until users are really exposed to your application, until you can prove that this is what they need, the work is not done. What can be done here? Well, ideally, when you finish any feature, And this is what it's called feature branching development with one trunk. So ideally, your pipeline starts on every commit to this master. And ideally, whenever each feature or on any commit to master, you also pull to the rest of the features. So for example, here feature A is ready, it's merged to master. Feature B is in development. You pull all the changes to feature B. So whenever you are developing in the feature branch, you are different from the master, only with the code that you have introduced. But then when you're ready, you commit to master, and this is where everything starts. This is where the whole cycle of build, test, release starts, and this is where ideally it should end either with a release to production in the hands of users, or potential release candidates, where you will aggregate some features and then release them. Again, in ideal situation, you will release every time. And also, release doesn't always mean that users are exposed to features, because continuous delivery in some way is against marketing, because marketing wants to go and show, okay, we've got this set of huge features, here we are a good company, this is what we propose to you. But continuous delivery says that if we release every time, the scope of change is small, and the smaller the scope of change is, the better. But then you can't market small changes. So what people are doing is that they're using feature toggling, dark launches, canary releases, wherever they deploy to production, but users are not exposed to features. But you can test those features. They're working, they're fine, and then you can, for example, enable it for some subset of users. But when time comes, when marketing is ready to say, here is the big release day, what will happen is just a change in configuration. All the features are already there. They will be just not owned. Again, it provides satisfaction to all of the parties here. And then again, until features are used in production, you don't know if they're done or not. So what can be practiced here? Deploy software at the end of the iteration. Done means release to production. It's a huge change and it's a huge step forward. But this is something that is the end journey. You can't say it's done until it's released to production. And if you take it as a goal, you will get there. And then starting to move quicker. Okay, you've got sprints, 2, 3, 4 week sprints. At the end of iteration, you release. But once you got an automated process, nothing will stop you to do it more frequently. Again, especially if you introduce feature toggling and everything that will make the marketing happy to turn features on and off. And you should do it more frequently. But then, you need to do it through optimizing the flow. Because if you've got it's called don't make ineffective more efficient. If you've got a wrong process in place, you can automate it. But then you will gain some time there. But sometimes you need to change the process, change the steps you need to take to release to production and just improve them in order to get somewhere. And if you think about optimizing the flow, there is an interesting contradiction here, because you need to honor existing processes. Even they're manual, because they appear there for a reason. Again, people don't just introduce steps in the release process because they think, let's do it. It was there for a reason. You can't change it. And then you need also to streamline and simplify all the processes and change the level, challenge the level of ceremony. If, for example, thinking aloud, right now CEO needs to make a decision to release something to production, just try to make it that, I don't know, vice president or the development manager or just developer needs. So try to constantly move where the decisions are made to the lower level. If you've got a good automated process, if you've got all the testing criteria, all the quality gates, you can go lower and lower in the process. And this is again the contradiction, because on one side you need to honor existing processes, but on the other side you need to streamline. But this ensures that you can't just say, oh, this is all bad, let's start anew. You can't just make a revolution, you need to make evolution. You need to iteratively, one step at a time, improve. And this is what Agile is about. Just one step at a time, make things better. I found this picture 2 days ago actually, and I decided to put it into presentation because the picture goes from the blog of the company called Industrial Logic, Joshua Knevsky. It was an article about modern agile, and it shows 4 different areas that modern agile company need to focus about: make users awesome, make safety a prerequisite, experiment, learn rapidly, and deliver value continuously. What I wanted to show is that I was talking about testing, and testing and refactoring is a very, very important part here. But also testing, and what I was talking about is making it safe to fail. Because you want this, if you want to change something under the hood, you want to refactor the application, you need some tests to guard you. That, okay, I'm changing the internal structure, but application is still releasable, it's still working. And if I want to try something, I will be able to quickly get the feedback, okay, it's a failure, I need to try to do it. And I want to do it to get this feedback in 1 hour, not in 3 weeks that something went wrong. And especially if you want to experiment, we can try things like this, or we can try things like that. Sometimes it's hard to make a decision, and it's good to say, oh, I think this decision is right, but maybe another one. If you can implement proper testing, you can get quick feedback, you can try both. Or you can try one, it doesn't work, you can try another one. And this is why we make it safe to fail. But also I was talking about deploy and release continuously. And you see it goes on integration of a lot of bubbles here. But it is important part of your software development lifecycle. Same is focus on flow. But this is just, somebody else showed that things I was talking today are important. Regardless, okay, those things are important as well, and this is a big story, of course, of agile. But if you think about testing and deployment, here they are. They are very, very needed. Collaborate and integrate frequently as well. To get some more confirmation, this is why I found agile. So lean. This hieroglyphs they say Kaizen is from Toyota production system. It means improvement. So lean appeared as an idea in Japanese manufacturers in 60s, 70s, 80s. It was popularized in the Western world. Why Japanese manufacturers outperformed everyone else in the world, and why Toyota still outperforms every other car producing factory except maybe Chinese. But why they're doing it better? They implemented lean principles. And then I won't go into details on this, but here some of the ideas are optimized for the whole. Create end-to-end process. See end-to-end process and how you are delivering software. Deliver fast by managing flow. Exactly again the same I was talking about, and build quality into the systems. One of the main idea why they made it so good and why they performed is this focus on quality. It's really, if you can't establish quality of your product, you can't get anywhere else. And this was proved in manufacturing, this proved in software development. Quality is the most important thing because this is how users see your application. Even if it doesn't have features but it's working correctly, users will be okay. But if it has all the features but it's constantly breaking, users won't like your application. I won't talk about anything else. And if the last thing is the culture, because really, okay, quality, release is everything. It goes through people, and if people don't feel protected and don't feel don't feel right, they won't get anywhere. And culture is not something that can be put externally from everywhere. Culture is each one of your job to do. And you know exactly the culture in your team, and you know probably how to improve it. And if the culture is bad, again, you probably feel it. But nobody but you can improve it. It can't be management decision. It can't be anyone else's decision. Either you want to be part of the good team or not. Either you also try to improve the culture of your team or not. And it goes through a lot of things. But most important here that I want to say is shared goal and collaboration. This is the most important part. Whenever you come to a team and say, oh, it's not my job to do it, sorry, why not? I'm a developer, I can't test software. Oh, okay. Or I'm a tester, I don't even want to look at the code. Well, why are you part of the team? You have a shared goal to make a kick-ass product. You want to do it and you want to release it to production. Why are you saying it's not your job? It is your job together with somebody else to do it. It is a shared responsibility. And whenever problems comes, what can go is that it's easy to blame people. Just so easy. There is one bias called fundamental attribution error. It means that whenever you're seeing somebody doing stupid things, it's probably because he's a bad guy. He's got bad character, he was not educated enough, he's a bad guy. But if you are doing something bad, oh, it's environment. I was put in a situation like this. And this is what is the fundamental attribution error about. You attribute somebody else's problem to his personality, but your own to circumstances. But this is what needs to be changed. Wherever something is happening, it's not people to blame, it's about process, about circumstance, and you can teach people. And it's easy to say, you are the bad guy because you did it wrong. But what are you gaining with it? Are you getting your team better because you're blaming somebody? Is it an improvement point if you blame somebody? No. And this is what can be changed, and trust can be built. But finally, transparency. You need to know how the decisions are made in your team and what happens and what are the rules. People need to know why they are doing things and how things are done. And especially why is the most important question, because on everyday work you need to think, okay, this is how decisions are made at this company. This is why we're doing this, and I'm acting in the best for these ideas. And then everyone will find their own way to act the best. But if it's not transparent, people just won't know about this. Or they will think, these decisions are made somehow without me. And this will also ruin the culture. So I want to close with this quote by Mary and Tom Popendick, that developing people in the system so that together they're capable of achieving successful results is the point of what I want to do. We develop software, and the software is the point, but how we create the teams and how we create the processes, this is how I want to trust people and to help them with the processes. So yeah, this was it. It was what I wanted to talk today about. Keep the product releasable, build the quality in. There's some main focuses that I want you to have. And improve continuously and build the right culture. Yeah, this is it. Well, thank you.
Thanks. When looking at the testing pyramid, could you elaborate your thoughts on where security testing should be? I'd say in all layers, but...
Yeah, let me show you where... So testing pyramid shows here the amount of testing, but security testing should be here. It should be part of the process, if you need it. Again, what is important here is that each team or each service, you need to think, how do I ensure quality? If security testing is part, how you ensure quality? It should be here. If it's not the part, it should not be here. But the amount of it, well, again, I can't give advice. You will need to know yourself, how do I test it? In most cases, you're testing it by third-party software, so you're not even creating any test cases. You're just running it.
So yeah, that would be a penetration test.
It can be a penetration test, it can be static security code testing, but then it goes all on the build stage. It can be, well, some like OWASP when you do it through end-to-end testing, because it mutates inputs and try to find the bugs. It can be different, but it needs to be part of the process if there is a decision to make it quality criteria. And you need to do it all.
It should.
The penetration testing probably can't go here because it's done mostly manually, again by third-party companies. Then you can do it separately. But anything that you can run all the time needs to be here. Any other questions? Or comments? Or disagreements? I don't know.
I think in our process we spend quite some time also on user acceptance testing. So we bring it to the customers, and it takes they spend a week on that. So where in the test permit is that an end-to-end testing?
So most probably here it is a separate thing because again release here. Okay, release here. It can be released to production, but it can be released to internal customers as well. And then for you automate fully the process here, but then they will spend time on the acceptance testing. Maybe if you automate everything before that, you can teach them, this is how you can automate your testing. But then they will probably want to do exploratory testing anyway. But you can make a decision how you can do it. Do you want to be inside this process? Do you want to be outside this process? How often do you want to deliver to them to do the testing? When do you want them to ask to do the testing? Because they can run the testing here, for example. One of the environments can be left for user acceptance testing for this particular feature. Just again, there are a lot of possibilities here. And not one good advice that I can give without working for a lot of time. But yeah, release can mean a lot of things. I think he says, make available to others. It is a general thing here. It can be users, it can be internal users, it can be different thing. I would say if you get that you can automate everything before that, this will be a huge step forward. And then you will just show by example how things can be done.
Any more questions to Pavel? No.
Okay.
Well, thank you very much.
Thanks.